Good evening. Welcome to my laboratory. This is another update of the Happy Fun Ball Simple Non-Over Unity Toy test bed. And let's see here. What we've got is the same basic test bed as before, except what I've done now, I realize that people don't have oscilloscopes or maybe don't want to use an oscilloscope for this. So what I've done is I've put together an Arduino program system that looks at basically the green LED over here on the control board that indicates when the coil is firing. And so we have a display of the pulse duration in milliseconds, the loop time also in milliseconds for it to make a complete loop, and the duty cycle in percent. And then over here is a counter that just counts the number of loops. Okay. And this track is 85 centimeters around. Doesn't look like it would be that much, does it? But it is. So we have a total track of 85 centimeters, and the ball weighs 16 grams. So if we know the speed, we should be able to calculate the kinetic energy of the ball. So we'll know how long a loop takes. We know the distance of the loop, so that will allow us to compute the speed of the ball. And then since we know the mass of the ball, we can also compute the kinetic energy of the ball by 1/2 mv squared. Okay, so let's see if it's going to work. Oops, try to stay on the track. So let's get a little start here and see what happens. Okay, so we can see that the ball is accelerating, and every 10th loop or so I have the Arduino go ahead and compute the velocity and the kinetic energy, and as you can see, it's not really all that much. The kinetic energy is in microjoules. So let's see, accelerating here. And then using that last value of 2.268 for a loop, we get those values for the velocity and the kinetic energy of the ball, if I did the math right. So far it's checked. The loop time right after the display of the velocity and energy is somehow buggy, so just discard that value and wait until you actually get the second or third value after the display there to calculate just a little bit over 1 millijoule is what we're calculating for the 1/2 mv squared kinetic energy. Using kilograms, meters, and seconds, the Système International. There's a bad one, and then we're back to counting accurately again. And I've checked these counts with the oscilloscope. They're within a millisecond of the oscilloscope reading, and the duty cycle is also within 1/10% of what the scope reads for a duty cycle. So these figures for the velocity and the kinetic energy should be fairly accurate. Okay, so now we know how much kinetic energy is in that ball when it's going just under 2 seconds around the loop. 1.97, 1.96 seconds. About 1.5 millijoules is all there is in terms of the kinetic energy of that ball. Okay, so now if I pull the power right there, and let the ball coast to a stop, now we have an idea to time all the motion until it actually stops right there. So now we have dissipated 1.5 millijoules in however long it took for that ball to go around and stop. So that'll give us an average power dissipation figure, and in watts. Okay, and it's not going to be very much. It's going to be under a milliwatt is the average power dissipation. And I am not going to tell you how much power we're putting into the system per pulse. I'm going to leave that for another update. And here we are accelerating. The Arduino sketch to do all of this is only about 30 lines long. It's a very, very simple sketch. I'm using the pulse in function to clock the pulse itself, and then simply using the microsecond or millisecond timer to clock the loop duration. And then I've also applied a slight adjustment factor to make the numbers agree with what I'm reading on the scope. So every 10th loop we will calculate the energy at the speed it's going on that most recent loop. Here we go. Alright, that's the Happy Fun Ball simple non-overing unity pulse motor with an Arduino speed and kinetic energy monitor. Thank you for watching.